All right, so this is 7.3 in Trig here, and we are reintroducing, I suppose, sine and cosine functions. So if we look at this do now here, it says define the sine and cosine functions as they relate to right triangles. Well, if you recall, when you first learned about sine and cosine functions, we learned, well, actually in tangent functions, we learned this concept called SOHCAHTOA. And what that meant is that when you're dealing with a right triangle, if you are taking the sine of a function, or the sine of an angle, so the sine of an angle would be equal to the opposite over the hypotenuse of that. So whatever angle is opposite of that, or whatever side is opposite of the angle, divided by the hypotenuse, the longest side. And that meant also that cosine is equal to the adjacent over the hypotenuse. And then our tangent of our angle is equal to the opposite over the adjacent. So that is kind of what this introduction is here. We're not going to really go into these right now. But again, this is just a refresher. So if I gave you a triangle, and again, it has to be a right triangle in this case. If this angle right here is theta, then this side is always the hypotenuse because that's opposite of the right angle. Because this is theta, this is our opposite side, and then here would be our adjacent side. And we're going to be dealing with that a little bit more in the next section. So let's just move on. So let's talk about sine and cosine. So what do they mean? This is something this is new, and this isn't something that was really defined in your geometry class. It's more, we're getting more into the trigonometry aspect of sine and cosine here. So what we say is if we're looking at a circle here, we know that no matter where we draw a line to the edge of the circle, it's always going to be the radius. And if you notice, no matter where I draw a line, if I draw a line right here from the center to here, we know that R, it can be here, the R is also this line. Well, also what you should notice is that if I create a triangle off of what we have here, the point that is on the edge of this circle is just a coordinate. It's x comma y. So the point is that we have an x value, whatever this value is here. We have a y value, whatever the vertical value is, and we also have an r value, and it creates a right triangle. So our formula for any of these, as you should recall from the Pythagorean theorem, is x squared plus y squared, and that will equal our radius squared. So instead of it saying c squared, in this case we're going to call it r, because that's what it is. So when we look at a sine function, sine of an angle, that's theta, is always equal to y, the y value, divided by r, the radius value. And your cosine function of an angle is equal to your x value, or your horizontal value, divided by your radius. So you can always think of it as this. Your sine is typically you're going to be your y value, and cosine is going to be your x value. So what's going to happen then is knowing one thing, if we are given information in this triangle, if we're given, say, 2 of the 3, so all we need is 2 out of 3 values. And once we know 2 out of 3 of the values, we can solve for the third. And you're going to see that's what we're going to do in a lot of this section. Okay? Now, one last thing that we want to understand is, don't forget our quadrants here. So you've learned this a while ago. The top right quadrant is quadrant 1. The top left quadrant is quadrant 2. The bottom left is quadrant 3. And the last one is quadrant 4. So it goes counterclockwise around. Okay? And again, don't forget. So angle right here, this angle in this triangle is always theta. That's the one you're going to see the most is theta when we're dealing with angles. Okay, so let's move on to the next slide after this introduction. Let's talk about the unit circle. So the unit circle is going to become really important when dealing with sines and cosines. The unit circle it's the same circle you saw above, but what we're doing is we're defining it as a radius of 1. That's saying that the radius all the way around is always going to be 1. So all of these values here going left and right, up and down, those are all going to be equal to 1. So what that means is the sine of theta is going to be equal, instead of us saying the sine of theta is equal to y over r, we can say it's equal to y over 1 or just y. That's why I was saying in general, sine of theta will be your y value. Cosine of theta will be your x value, and that works on the unit circle. So what does this mean? Well, let's take a look at a couple things here. So remember, we always start on this horizontal. So we always start at this point right here. So if I want to know, based on what's given to us here, we know all of our coordinates. If I want to know what the cosine of 90 degrees is, I can now figure that out because I know cosine is going to be like an x value. Well, 90 degrees is this point right here. That's 90 degrees. That's going from 0 degrees to 90 degrees. So you look at that and you say, what is the x value at that point? And it's 0. So we know that cosine is x value. And the x value at 90 degrees is equal to 0. So that's our answer. Okay, let's look at a different one. What about the sine of 270 degrees? Again, sine is our y value. So let's go to 270 degrees. So that's 90, that's 180. Down here is 270. So what's the y value at 270 degrees? It's -1. Okay? And then our last one that I want to look at is something in radians. So that way we can mix in radians. What about the cosine of pi? What's that equal to? And again, this requires you to know your radians. This is what I've been talking about with you knowing how to compare radians and degrees. We all know that 0 starts here. We all know that if you go all the way around a full circle, that's 2 pi. So that means we have here is pi halves. Here, over here, is going to be our pi. So 180 degrees is pi, 360 degrees is 2 pi. So again, cosine is an x value. So what is the x value at pi? It's -1. So our answer there is -1. And that's pretty much how sines and cosines are going to work dealing with pi's and degrees and things like that. Obviously, these are easier because they're right on the axes, and that's important for us to know that. So let's go on to the next slide. Okay, running through this, we have sine of theta equals 0. What does that mean? Well, what it means is when you see something like this, we are trying to solve for theta. We want to know what will theta equal for our sine to be equal to 0. So what you want to look at, again, is you need to know, first of all, that sine is a y-coordinate. Okay, we're looking for the y-coordinate. So basically what we're looking for is where is the y-coordinate 0? Well, the y-coordinate is going to be 0 here, and it's going to be 0 here. So we can start writing out what theta can be equal to. And this is where the, understanding how to add degrees and things like that. So we know it's going to be, theta can be 0, theta can be 180, because that's what this is, 180, and then basically every 180 after that. So the next one would be 540. Now, the other thing we want to pay attention to, we can also go in reverse. So it can be plus or minus 180 and plus or minus 540, and then obviously you can keep going after that. Also, you want to know what theta can be in radians. Obviously 0. And then again, what is this as radians? Well, it's 180 degrees, which is the same thing as pi. Plus or minus pi, because we can go in the opposite direction. And then plus or minus 2 pi. Maybe plus or minus 3 pi if you really wanted to keep going. Okay, so that's that. Now looking at sine of theta equals 1. Again, same idea. We know sine is a y value. So where are the y values equal to 1? Well, right here. That's the only place. So what is that as in degrees? Well, it would be at 90 degrees. And then it's going to be every coterminal angle after that. So you can keep adding 360, adding 360, adding 360. So we're not going to say plus or minus here. We cannot say plus or minus, because if we say negative 90 degrees, then that's not right, because that's -1. So what we need to do is this has got to be coterminal. So it's going to be, pretty much you're going to either add 360 or you're going to subtract 360.
Teachers, please excuse the interruption.
So what we can do is add 360, so that means we could say it's also 450. But we could also subtract 360, and we could say that that's negative 270. Okay? Now again, let's determine what it would be in radians. So obviously radians is, it's going to be halfway to the pi. So that's pi over 2. And then again, we can add 2 pi to that. So every time we add 2 pi to that, we can get, the next one would be 5 pi over 2. Or we could subtract 2 pi to that, okay? So if you subtract 2 pi to that, it's going to be negative 3 pi over 2. And again, you guys can figure out these calculations on your own by doing pluses or minuses, but that's the same idea. You're circling around until you get to the same spot again, so you're either adding 2 pi or subtracting 2 pi. You're adding 360 or you're subtracting 360, okay? So down here, I'm gonna go through this a lot quicker because it's the same idea. Cosine of theta equal to 0. Well, what is cosine? Cosine is our x-coordinate. So where's our x-coordinate equal to 0? Well, it's equal to 0 here and here. So theta is going to equal, and in this case, we can go back to our pluses or minuses because we're hitting both of them. So plus or minus 90. And then we have plus or minus 270, and then so on from there. If we do it in radians, we say plus or minus pi halves, and then plus or minus 3 pi halves, and again, you can keep going from there. On these ones, we're not adding 360, you're adding 2 pi. Here, because we're only going half a circle, we're only adding 180, and we're only adding pi, because obviously a 0 shows up more than once. 0 shows up here, and it shows here. Okay? All right, next slide. Here's the last thing we're going to do today. So this is where we talked about understanding that x squared plus y squared is going to be equal to r squared. Because here's what happens. We have already defined that the sine of theta is equal to y over r, and the cosine of theta is equal to x over r. So if that's the case, what you're looking at here is you want to see that if this is what we're saying, sine of theta equals 5 over 13, what that means is that 5 is going to be equal to y and 13 is going to be equal to r. So if I want cosine of theta, that means I need x over r. So how do I solve for x? Well, this is what we were talking about. Use this formula right here to solve for it. So we need the x value. So we're going to say x squared plus 5 squared equals 13 squared. And then we're going to solve for x. So x squared plus 25 equals 169. Subtract 25 to both sides, we get x squared equals 144. And then we actually, when we take the square root, we get a plus or minus. Because whenever you take the square root of both sides, you have to have plus or minus. So x is going to equal plus or minus 12. Do the same thing here. Here, because it's cosine, we have an x, but we're looking for the y. So that means we have 4 squared plus y squared equals 5 squared. So we have 16 plus y squared equals 25. Y squared equals 9. Y is equal to plus or minus 3. Last one. Again, it's sine, so that means we have the y and the r. So therefore, we have x squared plus 1 squared equals 8 squared. Then we have x squared equals, this is 64, that's 1, so we have x squared equals 63. So we have x, and I'm taking the square root of this, so it'll be plus or minus the square root of 63. Okay, and we're going to leave it as that. So now, how does this mean we plug these in? Well, now we know. X goes on top, r goes on bottom. So this is going to be plus or minus 12 over 13. This one's going to be plus or minus 3 over 5. And this one's going to be plus or minus square root of 63 over 8. So again, all you're doing is finding your missing piece or your missing letter. Once you find that missing letter, it's just the opposite because the sine is going to be y over r and the cosine is going to be x over r. So you'll have 2 of the 3 and you just got to solve for the third one, essentially using the Pythagorean theorem, but it just looks more like this formula right here instead. Okay, so again, don't forget to take your Edmodo quiz when you're done here. I know there's a lot of material here, but bring questions to class and we'll work on it from there.